We are tracking an unprecedented visitor, a ghost from beyond our sun's reach, the interstellar object 3I, Atlas. Plunging through the solar system at speeds approaching 130,000 miles per hour, or over 209,000 kilometers per hour for non-Americans out there, Atlas has become a crucible for orbital dynamics experts and astrophysicists. Its consistent exhibition of anomalies in composition, appearance, and trajectory forces us to fundamentally reevaluate our models of what a comet is. If 3I Atlas is merely a comet, then the fundamental physics manual must be immediately rewritten. But if it is not, the implications are far more profound, suggesting the presence of a relic or a probe behaving less like a wandering space rock and more like an object operating on a distinct mission plan. Our first comprehensive look at 3I Atlas came in October 2025 when the European Space Agency's ESA ExoMars Trace Gas Orbiter (TGO) deployed its KSIS camera to image the faint visitor as it passed through the Martian sky. The instrument team collected unusually long, 5-second exposures to compensate for the object's breathtaking speed and distance. When dozens of raw frames were stacked and calibrated, aligned precisely on the object's predicted motion and processed to suppress artifacts, the resulting image delivered a profound shock. The sharpened composite revealed a bright, hardened core surrounded by a faint envelope. Crucially, the image confirmed the near absence of a classic comet tail. The Martian orbiters provided a rare side view of the outgassing plume, which confirmed its compact nature. Photometric analysis established that the core, while unresolved due to the KSS resolution limit over 30 million kilometers away, was clearly broader than surrounding stars, confirming the presence of an extended, compact coma. The physical nucleus remains hidden within this haze, but thermal models indicate that the nucleus is believed to be massive. Its estimated size, with an upper limit of 5.6 kilometers, about 3.5 miles across, qualifies 3I Atlas as a behemoth by typical comet standards, rivaling some of the largest long-period comets ever measured in our solar system. This sheer scale is the first paradox. The object has survived eons of bombardment and radiation in deep interstellar space. Survival at this scale demands extraordinary toughness, suggesting a highly dense, uneroded core. For comparison, the vast majority of solar system comets have nuclei under 1 kilometer in diameter. A nucleus this large suggests it was ejected from its home system early on or is structurally far stronger than any comet we have studied. The missing tail was only the first surprise. Comet physics dictates a core rule: the tail must always point away from the sun. This principle is governed by radiation pressure, the physical push of sunlight, and the solar wind, both of which relentlessly shove material in an anti-solar direction. Any deviation immediately raises scientific eyebrows. Yet, initial observations of 3I Atlas showed activity in direct violation of this law. A faint glow initially aimed straight at the sun. This is described as the anti-tail morphology. While this activity later began to evolve into a longer anti-solar tail, the initial defiance of basic cometary physics, where material seems to be concentrated toward the star, presented a powerful challenge to the established framework. This morphology is often caused by an anisotropic gas or dust ejection mechanism, rather than the simple solar radiation-driven dust dynamics typical of standard comets. Astrophotographers Gerald Riemann and Michael Yeager, on September 25 from Namibia, using remote desert locations to achieve the darkest possible skies, later captured images revealing the object glowing bright green. The color green in comets is typically created by diatomic carbon or C2 bonded carbon atoms when exposed to solar ultraviolet UV radiation. This is a standard and easily explained phenomenon. However, extensive spectroscopic observations conducted with major telescopes, including the European Southern Observatory's ESO, Very Large Telescope, VLT, found that 3I Atlas is actually deficient in these carbon chain molecules. It is classified as a C2 depleted comet. Despite the lack of the expected chemical component, the object is clearly glowing green. This chemical anomaly currently lacks a natural explanation, leading to speculation that an unusual compound or a non-natural light emission process is at play. Adding further complexity, the analysis of light polarization provided still another clue, showing a deep negative polarization minimum, -2.7%. This signature is described as unprecedented among comets and asteroids, and fits models indicating the dust is darker, fluffier, and more complex than typical cometary material, likely composed of highly porous magnesium silicate grains mixed with ice. Piece by piece, the evidence confirms that 3I Atlas is not merely a statistical outlier, but a profound physical one. The chemical composition revealed by instruments like the James Webb Space Telescope, JWST, and ground-based telescopes, Keck and VLT, presents multiple findings that resist easy categorization within known comet nurseries. Spectroscopists found strong, unmistakable nickel emission lines. This is notable, but the expected companion element, iron, was found to be temporarily absent or highly depleted. In solar system comets, iron usually outshines nickel by orders of magnitude, or at least appears with it. In Atlas, that ratio was inverted for a significant period of observation. This suggests that the material itself may have been forged in an environment unlike any we know. This metallic activity occurred at an unusual distance. While comets often contain metal, it typically only evaporates into the coma when the object is extremely close to the Sun, inside 1 AU. Yet, nickel was detected when 3I Atlas was still between Mars and Jupiter, at 3.14 AU. No reasonable explanation exists for the release of metal at such a distance, a phenomenon which is 10 to 100 times too early by standard cometary models. The scientific explanation proposes the carbonyl theory, being the most accepted. Natural theory suggests the metals are not in pure form, but are bound in highly volatile compounds called carbonyls, specifically nickel tetracarbonyl and iron pentacarbonyl. Nickel tetracarbonyl has a lower sublimation point than the iron compound. This explains the initial nickel dominance. As the comet warmed, the nickel carbonyl vaporized first, followed by the iron carbonyl as it drew closer to the Sun, which was indeed observed when iron carbonyl appeared later at 2.64 AU. The non-natural hypothesis proposes it's an industrial relic. Harvard astrophysicist Avi Loeb has pointed out that this industrial-scale refining of nickel without iron is a process used in the industrial refining of nickel on Earth, called the Mond process. The chemical composition is thus consistent with the exhaust or byproduct of a nickel-rich metal alloy exposed to carbon monoxide, offering a profound chemical connection to a technological process. Furthermore, JWST's near-infrared spectra confirmed the presence of both water and carbon dioxide. The measured water to carbon dioxide line fit lands at 57%. To put this into perspective, the median water to carbon dioxide ratio for solar system comets is typically around 12%, with a range from 2% to 30%. 3I Atlas's ratio is nearly 5 times the solar system median and is far beyond the high end of the common range. This abnormally high carbon dioxide ratio suggests a different ice mixture or a formation history originating in a colder, more volatile-rich region of space, perhaps an entirely different star system's outer gas giant region, where carbon dioxide could condense more readily. This single measurement places 3I Atlas in an entirely new chemical category. The trajectory of 3I Atlas challenges orbital dynamics experts, perhaps more than its chemistry. Atlas did not plunge into the solar system from a random, steeply inclined angle, as previous interstellar visitors like Oumuamua and 2I Borisov did. Instead, Atlas arrived almost precisely along the flat plane of the major planetary orbits. The likelihood of an object from deep space accurately threading itself into this narrow orbital disk is statistically minute, estimated by some specialists to be less than 1%. While it is plausible that interstellar objects ejected from the galactic plane might naturally align with the solar system's ecliptic plane, the rarity remains a significant talking point. The subsequent path only deepens the intrigue. The trajectory involves close passes near Mars, and then later, Jupiter, in March 2026. This sequence, a rapid succession of encounters with two gravitational giants, is what spacecraft engineers recognize as a gravity assist maneuver, which is used to bend a probe's path and boost its speed or adjust its trajectory. For a random interstellar object, this apparently orchestrated sequence is described as almost unheard of. The trajectory experts have initiated Monte Carlo simulations to test the likelihood of this alignment being a cosmic accident, but so far, the rarity remains evident, lending weight to the idea of a path designed for maximal observation or interaction with the inner solar system's gravitational field. If 3I Atlas were a standard comet, sublimation, the process where internal ice converts directly to gas, would release thrust, causing erratic movements called non-gravitational acceleration, NGA. Typical comets change their velocity and direction frequently, as their volatile ices unevenly vent gas. However, the velocity and trajectory of Atlas have remained almost perfectly consistent for the entire observation period. Its daily NGA fluctuation is only about 1.5 kilometers. This stability is exceptionally low when compared to other large comets. 2I Borisov, previous interstellar visitor, fluctuated over 100 kilometers per day. Hale-Bopp solar system comet of comparable size, moved by an average of over 10 kilometers per day. Atlas's movement is roughly 10 times steadier than Hale-Bopp and 100 times steadier than Borisov. The only known natural explanation for such low NGA is that the object is anomalously massive and dense, meaning the thrust from outgassing is too small to measurably deflect the nucleus. This unusual steady course has led some to suggest it appears intentional, as if it is being guided through the solar system. The confluence of independent anomalies, strange chemistry, a trajectory resembling a flight plan, and structural defiance of physical rules has prompted extraordinary hypotheses. Harvard astrophysicist Avi Loeb has publicly suggested that the cumulative evidence elevates the probability of a non-natural origin above background noise, advocating for the probe or relic hypothesis. One compelling, yet unverified theory links 3I Atlas to the WOW signal discovered in 1977. Astronomers have determined that Atlas originates from the general direction of the constellation Sagittarius. This is the same direction from which the powerful 72-second narrowband radio signal originated. The WOW signal was detected at 1,420 MHz, the universal marker of the hydrogen line, suggesting it was potentially intended as a message. A theory suggests that Atlas, which would have been at the outer edge of our solar system, beyond Pluto, in 1977, might be the source of the signal. While this theory has not been proven true, it remains an open possibility, as it also has not been proven false. To move beyond theories, high-resolution data is essential. The high-resolution imaging science experiment HiRISE camera on NASA's Mars Reconnaissance Orbiter (MRO) was scheduled to capture 3I Atlas during its closest Martian approach. The HiRISE camera, with its 30 km per pixel resolution, was expected to provide the highest fidelity image yet, potentially resolving the nucleus size and definitively constraining the NGA theories. However, the operation was complicated by various factors, including an alleged technical glitch or data processing backlog, leading to the unreleased status of the crucial HiRISE images as of late October 2025. This has created a data access crisis. The absence of raw data and full calibration products meant outside experts could only speculate. The community's demand for full transparency grew louder, as without timely access to the full data stack, the boundary between a genuine signal and a photographic artifact remains a matter of trust and protocol. The situation has created pressure for new international agreements to mandate automatic data sharing for interstellar objects, with the UN Committee on the Peaceful Uses of Outer Space currently debating a rapid response framework. For now, the crucial high-resolution images from Mars orbit remain unreleased, and the available data confirms only that 3I Atlas does not conform to known natural categories. The interstellar object 3I Atlas presents a spectacular, multifaceted challenge to astronomy. Its size, its structural stability, its inverted metal chemistry, its exotic carbon dioxide abundance, and its eerily orchestrated trajectory all point to one conclusion: this object is physically and dynamically unique. Whether it is a natural extreme, a supercomet from an alien star system, or the ultimate technological artifact cloaked in a cometary facade, its study is a critical test of our fundamental knowledge of the cosmos. Every new data point, released or withheld, forces us to question not just the object itself, but the assumptions we hold about the universe. The answer to the mystery of 3I Atlas is out there, waiting in the data. What do you think about 3I Atlas? Let me know down below.